Welcome back to our videos, everyone. It's been a while since we had our last video. All right, the second section of the circle unit dealt with finding all these different types of angles within a circle. Okay, so we're pretty good on that. So what we're going to turn our attention to this last third is actually how to find the lengths of these segments here. How do I find the actual lengths of these segments? And we're going to start out with chords today. All right, how do I find the measures of chords? First thing, it's been a while, so hey, why don't we start off with a little proof? All right, that'll lead us into the big theorem for today. So if you guys take a look at your proof statement, anybody remember what unit we saw that proof statement in? We've seen this before. This isn't anything new. We have seen this proof statement before. Anybody remember what unit? Can you remember what unit we saw this proof statement in before? If you're saying the similar triangles unit, you are absolutely correct. That was our product of the means equal product of the extremes reason for when we put that as a statement. All right. So what we're going to need to do first, and you're going to pause the video as I will, you're going to try to prove these two triangles similar to each other, similar. And if you remember, anybody remember the main way of proving triangles similar, specifically in a proof? Yep, it was angle. So what I need you guys to do right now is pause the video, see if you can find two pairs of congruent angles and write it down in here, and we'll see if we match. If you find one, fine. If you need help with the second one, you'll see it when I resume the video. All right, so here we go. Try to get those triangles similar to each other. Okay, back together. I'm sure most of you found the vertical angles that were congruent, which is my statement 2. Also, C is congruent to A, or you could also have B congruent to D, because take a look. I know this has been a while since we talked about this theorem, but C and A are both inscribed angles, and they're both drawn to arc BD. So if you have inscribed angles drawn to the same arc, they need to be congruent. Okay, so make sure you add that in there. Pause the video if you need to add that in. And again, I could say that for angle C and A, or I could say that for angle B and D. All right, so now that I have both pairs of angles that I need, I can say triangle CEB, similar, make sure you don't write the congruent sign, CEB is equal to similar to AED by angle. All right, the proof statement is not our next step. If you remember back in that unit, after triangles are similar, corresponding sides are in proportion. We called that CSS TP. All right. That congruence, this proportion right here in statement number 5, that proportion can be found using the proof statement. So if I put AE here and I need to multiply it by BE, it's got to go diagonal from it because I'm going to cross multiply here, remember. And then CE and DE. Okay, by CSSTP. Now I cross multiply and I say that AE times BE is equal to CE times DE. And that's by product of the means equals product of the extremes. Okay? So you right now, you may not realize it, but doing this review proof and similar triangles, you have proven how to find the lengths of chords now. Okay? So let's write our theorem here down. Products products, which means we're going to, just a little note, multiply. Products of the parts are equal. Okay, products of the parts are equal. And this is for two chords only. So let me just do a little quick example back up here. Okay, again, products of the parts are equal. So if I go back up here, and let me say CE is 5, this is 4, that's 2, what's the length of EA? Here's what we just proved, that 5 times 4, the product of one part of a chord is equal to the product of the other part of a chord, the other chord, 2 times x. That's what we're saying. That's what we just proved by means and extremes are equal. Okay? That 2 times x, those two parts are equal to 5 times 4, the other two parts of another chord. Okay? So that's what we're saying right now. Part times part equals part times part. All right? For 2 chords only. 2 chords. Doesn't work for secants or tangents. 2 chords. All right, so let's go a basic one here. Number 1. You see I have 2 chords that intersect. So let's take one chord. Let's take this green one right now. What's the product of their parts? 8 times 2.5. And that's equal to, now take the product of the other one, x and 2. So you have 2x equals 2.5 times 8. It's 20. X equals 10. Okay, so that's how I can apply that theorem. All right, now it gets a little crazy now. You know, I wish they were all that basic. Now we go to the next one. Okay, do you see the 2 chords that are intersecting? Let me highlight them. Here's the first chord in pink. And here it comes the second chord in yellow. Right there. Do you see the 2 intersecting chords? All right, let's take the easier part. Let's take the pink one. What are the product of their parts? 8 and 10. Okay, equals, now let's take the product of the next chord, which is the diameter. Well, one part of it's x. What about the other part, guys? Okay, one part is x. What about, I'll do it in blue now. What about this part I'm putting in blue? Because it's x times whatever that blue one is. Well, let's see. 12 is the radius they give us. 12 is the radius, which would mean the diameter is equal to 24, right? So that whole diameter is 24. If that part's x, the other part's got to be 24 minus x. A little tricky there. All right, so 8 times 10, the 2 parts of the pink chord, equals the 2 parts of the yellow chord, x and 24 minus x. I know that 24 minus x is a little bit tricky, but that's the way it is right there. Okay, so now here we go. We got 80 equals 24x minus x squared. Uh-oh, we see an x squared, don't we? That means we're probably going to have to factor. Can't factor unless one side's equal to 0. I never like my x squareds to be negative, so I'm going to bring everything over to the left. Bring everything over to the left. X squared minus 24x plus 80 equals 0. You are going to pause the video right now and find 2 numbers that multiply to 80 and add to negative 24. If you have to do the y equals trick, you do it. All right, so go ahead, pause the video. 2 numbers that multiply to 80, but add to negative 24. So you should have had negative 20 and negative 4. Now keep going. X equals 20 and x equals 4. Now usually we're in the habit in class of rejecting, if I plugged it back in, giving me a negative length. 20 and 4, when I plug it back in, do not give me a negative length. So do I accept both? Should I accept both? No, you should not. No, you should not. No chance. All right, there's one of these we can definitely confidently eliminate. Look at 20. You're going to tell me this piece right here is 20 when the radius is 12? That part right there is less than the radius. So how could it be longer than the radius? No chance. So 20 is out. X equals 4. All right, moving on. Find the length of the chord CD. If it is 3 centimeters from the center and the radius is 5. Okay, so let's write down in the diagram what we were just given. It's CD if it is 3 centimeters from the center. So 3 centimeters from the center. And the radius is 5. Got it. All right, hold on. If the radius is 5, if that piece is 3, this piece must be 2. Everyone see that if the radius is 5? So that's how I can fill those in. and it's asking me for chord, what's the length of chord CD? All right, well, take a look. This is going to go back, and we're going to use this theorem again during homework, so don't forget about it, is, hey, if I have a diameter perpendicular to a chord, guys, what happens to the chord? It should be getting bisected, right? So if I call one piece X, I can call the other piece X. And now I have, even though it's a diameter, it's still a chord. I have two chords that intersect. So let's first do CD. What are the two parts of CD? Part times its other part is equal to, now go to the diameter, part of the diameter 2 times the other part, 3 and 5, which make 8. So you get x squared equals 16. X equals plus or minus 4, but I don't need the negative 4. I just need positive 4. Okay, so again, part times part equals part times part. And then, we're not given a diagram here. Looks like we're going to have to do our own, kids. Here we go. Okay, so next up, chords A, B. So chord A, B, and RS intersect at point E. Got it. Next up, so that AE is 3, EB is 16, and RE to ES are in a ratio of 3 to 4, so we know what the deal is. Put variables with them. RE 3x, ES 4x. All right, so we have two chords that intersect, correct? We have two chords that intersect each other, so ready? Take one. Product of their parts, 3 and 16, equals the product of the other chord's parts, 3x and 4x. So I have 48 equals 3 times 4 is 12, x times x, x squared. Divide both sides by 12. X squared equals 4. X equals plus or minus 2, but I only want the plus part, so 2. That doesn't make us a winner because it said find RE and ES, so go ahead, plug it back in, everybody. RE should be, let's see, 3 times 2, which is 6. ES should be 2 times 4, which is 8. Okay, and if you check it, 6 times 8 is 48, and 3 times 16 is 48. So that's how I know it checks out when I multiply each part. All right, so that's the main concept from today. All right, we're not done yet. I got one little thing I needed to add into this section here, but when you have two chords that intersect, the product of their parts are equal, okay? So real quickly, one more new theorem, and that deals with, we're still dealing with chords, so that's why I fit it in here. If you have two chords that are parallel to each other, okay, two chords that are parallel, their arcs are congruent. The arcs in between are congruent. So if AB and CD are parallel, arc AC is congruent to arc BD. Okay, if two chords are parallel, the arcs in between are congruent. So here we go. Let's apply it real quick. I have AB and CD are parallel, which automatically tells me, ready, that the arcs in between are congruent. So CA is congruent to DB. We need to find arc CA, given that that's 80. All right, no problem. Remember, what was COD up above here? That's a diameter, so you have a semicircle right here. All right, you have a semicircle which equals to 180. So arc CA will be equal to 180 minus that 80 we were given, divided by 2. And that'll be 50 degrees. Okay, 50 degrees. All good? Okay, so I'm going to let you guys try out these last two here and see what you got. All right, so go ahead, pause the video. Let's see what you got. Okay, back again. Here you go. For the second one, if AB and DC are parallel, that means arc AD and arc BC are congruent, so they're both 80. And now I know all the arcs except for one, so that's why I set it equal to, subtracted everything from 360 and got 140 for the missing arc. Arc CD. A little tricky on the last one, maybe. I was given AB and DC were parallel, which would mean arc AD and arc BC are congruent, so they're each 30. Now, how did I get arc DE and arc CE? How did I get these two arcs right here to be congruent? Because I used a little theorem that said, hey, the chords were congruent, D, E, and C, E. Those two chords were congruent. So congruent chords imply congruent arcs. All right, again, congruent chords imply congruent arcs. So I have 360, the whole circle is equal to the 50, the 30, and 30 I knew, plus the two congruent arcs, X and X, give me 360, and I solved X was equal to 125. All right, so you got 2 pages there for homework. Good luck, and I'll see you at the next Google Meet.